Hello. Yesterday we looked at 9.1, which practically focused on the momentum, introduction to momentum. So while looking at the introduction, we started with the first law of Newton, which is sigma F equals 0, which means the resultant force acting on an object is equal to 0. What does that mean? It means unless there is a force, an object will remain stationary or will continue to move at a constant speed in a straight line, forever. So we then talk about the connection between this first law and the second law, which is sigma F equals ma, which is the resultant force acting on an object equals to mass times acceleration. We then went on to say the connection between the first law and the second law to the momentum is that the first law is saying that you need a resultant force for momentum to take place. So if there is no resultant force, there is no change in momentum, because if there is no change in momentum, there is no acceleration. And the second law is basically saying because there is a change in force or resultant force, then there is acceleration. And then we then went on to open up that formula for force, which is ma. We want to find the definition for acceleration, which is v minus u over t, which we already know. And then we open it up to become mv minus mu over t. We also spoke about the possibility that the mass of an object will remain constant, in which case this then becomes m delta v over delta t, which means the mass is constant, but the velocity is changing. We also look at the possibility that the velocity can be constant and the mass can be changing, as in the case of a rocket that is being shot into space and then is losing some of its mass as a result of discharging some of its fuel. So this is all we did yesterday, and then we went on to look at the connection between the time of impact and the force itself. And we say if we can bring force times time together, we end up with change in momentum. Whether it is this case or that case, it's still going to be a change in momentum. We then say this is called the impulse. So you can then express impulse as the product of force times time of impact or the change in momentum. Okay? We also then talk about the graph, the force time graph, which means that if we have a graph with force there and the time in second, if the force is constant and is applied over a particular time t, we can find the area under this graph. Okay? And the area under this graph is the impulse. Okay, which is the same as change in momentum. So that summarizes 9.1. So in the next video clip, we are then going to go on, proceed from there and look at 9.2. We did some worked example, which I'm sure that you seem to understand very well. So unless somebody needs help with that, we can then come back to look at it. Thank you.